Hello friends, welcome back. Hearty welcome to you. As part of pair of straight lines, let's look at the condition that needs to be satisfied by a second degree general equation to be represent a pair of straight lines. So if ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 represents a pair of straight lines, then abc plus 2fgh minus of af square minus bg square minus ch square is equal to 0. Also, h square is greater than or equal to ab, g square is greater than or equal to ac, and f square is greater than or equal to bc. Now let us see how to do this derivation. First, let's write down the second degree general equation. What we have: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Now, if this represents a pair of straight line, then can I write them as a combined equation of two straight lines like L1x plus M1y plus L1 into L2x plus M2y plus N2 is equal to 0. Now let's compare the coefficients of these two equations because they both represent the same thing. What I get is a equal to L1 L2 because ax square is, if I multiply this, I have L1x into L2x, L1 L2x square. Next, 2hxy, so where xy term will come when I multiply L1x with M2y and M1y with L2x. So can I go ahead and write down 2h equal to L1 M2 plus L2 M1. We are comparing xy terms here. 2hxy, xy comes when you multiply L1x with M2y and L2x with M1y. Next, after that we have by square. Y square term comes when you multiply M1y with M2y. So M1 M2, b equal to M1 M2. Not only that, we have 2gx. So x comes whenever you take the x term, multiply with a constant, and also x term with the constant. So can I write down L1 L2 plus L2 N1, L1 N2 plus L2 N1, that is nothing but 2g, L1 N2 plus L2 N1. Similarly, 2f is when you have y comes when M1y is multiplied with constant term and M2y is multiplied with constant term. So I can write down M1 N2 plus M2 N1, and the last one is constant. C comes whenever you multiply two constant terms. So I can write down C equal to N1 into N2. Now, so once we have A equal to L1 L2, 2H is L1 M2 plus L2 M1, B equal to M1 M2, we have what we did. We have been given that this second degree general equation represents a pair of straight lines. So we have taken it as a combined equation of two straight lines. One is L1x plus M1y plus N1, another is L2x plus M2y plus N2. Now when you multiply this, that should represent this equation. So when we compare the coefficients of the terms, x square term coefficient is L1 L2, but it is A. So like that we can compare all x square term, xy term, y square term, x term, y term and constant term. This is what we got. Now what we have to prove here is ABC plus 2fgh equal to AF square plus BG square plus CH square. So we'll try to write down ABC in terms of L and M and N so that we can easily solve it. So let's go ahead to the next step. Now what's the equation? What's the condition we have to prove? ABC plus 2fgh minus AF square minus BG square minus CH square equal to 0. Now let's look here what we have. We have A, B, C, fine, we have that. Then we have 2G, 2F, 2H, but here you have 2FGH. So I want to multiply this whole equation with 4 so that I can directly multiply 2G, 2F, 2H for this. So what I want to do now, multiply with 4. So it will become, when I multiply with 4, I'll write down into 4. When I do into 4, it will become 4ABC plus 4 2s are 8FGH is equal to 4AF square plus 4BG square plus 4CH square. So I have to prove that left hand side equal to right hand side. Now let's substitute the values of ABC and see what will happen. We have A equal to L1 L2. So can I write down L1 L2? Then B is equal to M1 M2. So it will be 4 L1 L2 M1 M2 N1 N2 plus 8 FGH, that is nothing but 2G into 2F into 2H. So I can write down that as 2G into 2F into 2H or 2H into 2G into 2F. I can write it as L1 L2 plus L2 N1 into M1 N2 plus M2 N1. Multiply that with L1 M2 plus L2 M1. Now this is my LHS. This should be equal to RHS. That is nothing but 4AF square. Now how can you write 4AF square? Let's do little bit of calculation here. 4AF square is nothing but A into 2F whole square. This is B into 2G whole square. This is C into 2H whole square. Maybe I can fill this one too. 2G into 2F into 2H. And here I have 4 into A into B into C. This is what we have done. So A into 2F whole square is nothing but A is L1 L2 into 2F. 2F is M1 N2 plus M2 N1. M1 N2 plus M2 N1 whole square plus B is M1 M2 into 2G whole square. 2G is L1 N2 plus L2 N1. L1 N2 plus L2 N1 whole square plus N1 N2 into L1 M2 plus L2 M1. I hope that's okay. Whole square. L1 M2 plus L2 M1 whole square. 1 minute. So we have to prove that L1 4 L1 L2 M1 M2 N1 N2 plus L1 N2 plus L2 N1 multiply with M1 N2 plus M2 N1 multiply with L1 M2 plus L2 M1 is equal to L1 L2 into M1 N2 plus M2 N1 whole square plus M1 M2 into L1 N2 plus L2 N1 whole square plus N1 N2 into L1 M2 plus L2 M1 whole square. If I am able to do that, then I have proven that whatever the condition needs to be satisfied, that is ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. Now we will take the LHS and we will try to obtain the RHS. So let's take couple of steps. We need actually more than 2 steps to do that. It will take at least 3-4 minutes. Let's try to finish it now. Okay, right. We'll start with LHS. So I will not touch this part. I will leave it here. I'll focus on this. I'll multiply them. Then I'll try to take common and see how simply we can get this in 3-4 steps. So first we have to multiply. So I'll first multiply M1 and 2. These two I will multiply. Then I'll multiply this in the next step. So let me go ahead to the next step. LHS is what we are starting with. LHS is 4 L1 L2 M1 M2 N1 N2 plus L1 N2 plus L2 N1 and multiply that with we have 2, so we should get 4 terms. So let's get that 4 terms. First, m1 n2 into l1 m2. So that's nothing but equal to l1 m1 m2 n2, l1 m1 m2 n2. I'll write down l1 m1 m2 n2 plus m1 m2 into l2 m1, that is l2 m1 square n2, l2 m1 square n2. So we are done with l1. We have taken m1 n2 multiplied with this whole thing now. Then we will go to m2 n1, multiply with this, then afterwards with that one. So the next step will be m2 n1 into l1 m2, which is nothing but equal to l1 m2 square n1 plus m1 m2 n1 into l2 m1, that is l2 m1 m2 into n1. I'll repeat that again. m2 n1 into l2 m1, that is l2 m2 m1 n1. So these are our first 4 we got. Now we have to multiply this so that we can get all the 8. So let us see, we can fill them. We'll go to the next step. We'll write down. First will be 4 L1 L2 M1 M2 N1 N2 plus, now what we will do, we'll take L1 N2, multiply this whole thing, then we will take L2 N1 and multiply this whole thing. So first we will do L1 N2, multiply with each term, we'll do multiply with each term, then we go to second term and multiply everything in the second expression. So first we'll do that, L1 N2 into L1 M1 M2 N2, that is nothing but, I'll write down here, that is equal to L1 square M1 M2 N2 square. So can I write down L1 square M1 M2 N2 square plus L1 N2 into L2 M1 square N2, that is nothing but L1 M2 L1 L2 M1 square N2 square. So I'll write down L1 L2 M1 square N2 square M1 square N2 square plus, let's go to the next term, that is L1 N2 into L1 M2 square N1, that is L1 square M2 square N1 N2, L1 square M2 square N1 N2. The next one is L1 N2 into, so the last one L1 N2 into L2 M1 M2 N1, that is L1 L2 M1 M2 N1 N2. So I can write down L1 L2 M1 M2 N1 N2. 4 are over. Let's go to next 4 now. Now we'll take L2 N1, multiply with this, multiply with this, multiply with this, and multiply with this. So let's write down that L2 N1 into L1 M2 L1 M1 M2 N2, that is nothing but L1 L2 M1 M2 N1 N2 plus L2 N1 into L2 M1 square N2. So can I say L2 square M1 square N1 N2, L2 square M1 square N1 N2. Next plus L2 N1 into L1 M2 square N1. So can I write down L1 L2 M2 square N1 square, L1 L2 M2 square N1 square plus, so we have 1, 2, 3, 4, 5, 6, 7. The last one L2 N1 into L2 M1 M2 N1, that is L2 square M1 M2 N1 square, L2 square M1 M2 N1 square. So this is what we got. Now what we will do, we will focus on wherever the squares are there, because in the final answer we need to have squares. So we'll focus on wherever the squares are there and we separate them according to that. So let me write down here how we want to do that. I see L1 square, I see L1 square N2 square. Where is L1 square N2 square again? Let us see that. L1 square N2 square okay, and we have, okay, let me just go back. We will take, if you leave that, I have M1 M2 common here. Where I have M1 M2 again, I can take M1 M2 common here. I can also take M1 M2 from one of this. Okay, fine. Then let us see where is L1 L2 common. We take another color for that. We take L1 L2 common. So L1 L2 is common here. Again L1 L2 is common here. Now next is N1 N2. Where is N1 N2 common? Let's put another color for that. Let us take N1 N2. We have N1 N2 common here and we have N1 N2 common here. So what I will do now is, I'll write down next step, I'll show it to you. First I'll take that M1 M2 common. I will have L1 square N2 square plus L2 square N1 square plus, now I have here 4 L1 L2 M1 M2 N1 N2 and here 2 more, 6. So we can give them to 2 2 2, 3 of them. So if I take M1 M2, left out is nothing but 2 L1 L2 N1 N2. So I can go back and write it as 2 L1 L2 N1 N2. Similarly, the next one what I can do is, now I can take L1 L2 common, then it will be L1 L2 if I take common, I have M1 square N2 square, M2 square N1 square, and I can take again 2 more from there. So it will be M1 square N2 square plus M2 square N1 square plus 2 M1 M2 N1 N2 plus N1 N2 into, next one, if I take N1 N2 common, I have L1 square M2 square. So it will be L1 square M2 square plus L2 square M1 square. If I take N1 N2 out from this thing, I will left out with L1 L2 and M1 M2. So I can write down that 2 L1 L2 M1 M2. So this is what we can simplify this. Now only one thing we have to understand, that is we have 4 L1 L2 M1 M2 N1 N2 plus 2 more are coming, 6 are there. So we divided that into 2 here, 2 here, 2 here. Now the beauty is I can take M1 M2, left out is L1 L2 N1 N2. If I take L1 L2, left out is M1 M2 N1 N2. If I take N1 N2, L1 L2 M1 M2. These are all nothing but becoming 2ab terms of these respective equations. A square plus b square plus 2ab, a square plus b square plus 2ab, a square plus b square plus 2ab. So the next step will be nothing but our final step, that is M1 M2 into L1 L2 plus L2 N1 whole square plus L1 L2 into M1 N2 plus M2 N1 whole square plus N1 N2 into L1 M2 plus L2 M1 whole square, which is nothing but equal to, if you go back and substitute what we have here, M1 M2 is B and this is 2g whole square plus A into 2f whole square, we can check that, plus 2c into 2h whole square, that is nothing but 4af square plus 4bg square plus 4ch square. Or you remember, actually what we need to prove is this. If you are able to prove that, then LHS is equal to RHS, because What we did, we multiplied with 4, and we have multiplied with 4 so that we can do the calculation easily. And so we have proven that ABC plus 2FGH, that is our LHS. Our RHS is nothing but, so we multiplied with 4. So you take out 4, you have AF square plus BG square plus CH square. So ABC plus 2FGH equal to AF square plus BG square plus CH square. Now what is the next condition we have to prove? H square is greater than or equal to AB. Let us see how we can do that. We know that H equal to 2H equal to L1 M2 plus L2 M1, and A is equal to L1 L2 and B equal to M1 M2. Now what's the meaning of H square is greater than or equal to AB? Nothing but I have to prove H square minus AB is greater than or equal to 0. But what is H according to this condition? We have L1 M2 plus L2 M1 divided by 2 whole square minus L1 L2 into M1 M2. That's equal to, you take LCM, it will be L1 M2 plus L2 M1 whole square minus 4 L1 L2 M1 M2 divided by 4, which is equal to L1 M2 minus L2 M1 whole square by 4, which is always positive because square of a value is always positive. Now how we got this? A plus B whole square minus 4AB equal to A minus B whole square. A minus B whole square is always positive, so H square minus AB is greater than or equal to 0. So similarly you can prove for the remaining two also, that is G square is greater than or equal to AC and F square is greater than or equal to BC. So that's a derivation which may not be needed in exam, but if you are interested, you can just go through that and see how we derived it. So thanks for your time and support. Bye for now.